All right, here we go, everybody. Was waiting for things to get started there. Good afternoon. Welcome to today's weather discussion. I am looking forward to talking to you guys about the basics of weather. Let me introduce myself real quick. My name is Tim Bryce, and I'm a meteorologist with the National Weather Service in El Paso, Texas. I'm going to show you on a map where everybody is located compared to where you guys are. Also joining me on the call is a forecaster from the Pocatello office. There's Mr. John Keys. How are you doing, sir?
Doing pretty well. Hope everyone else is doing well there in Washington, across the rest of the country as well.
Yep. And then also joining me on the call is Mr. James. Mr. James, how are you doing, sir?
Good afternoon here on the East Coast, at least. It's 4 o'clock where I am. I know it's a little bit earlier in the day for you guys, but so far so good, and excited to talk to you guys today.
Yeah, Mr. James works in our Raleigh office, and like I said, I'm going to show you guys on a map where everybody's located because I think that's kind of cool. But just so you guys understand what we're going to do today, all three of us are going to give a presentation, and it's going to last, I think, maybe 45 minutes or so. We'll pay attention because we're going to be occasionally asking you guys questions. And then at the end, we may have time. I'm hoping we may have time for 1 or 2 questions. So if you have any questions, hold them in your head and think about them. And at the end, we'll try to answer a few questions. Does that sound like a good plan?
Yeah.
All right, let me show you guys on screen so you guys can see yourselves. So there you guys are. You guys can wave at yourselves. Very good. All right. So let's begin the presentation. So I like to do this because it makes a cool kind of effect. Boo. Let's see. Did it share? Did I?
Not yet.
Uh-oh. It's locked up on me here. So
let me see if I can get it to work here.
Yeah, see if you can get it to work because my screen share just locked up on me.
Mine, it looks like it came up on mine. Hold on.
Okay, why don't you go ahead and give the first section? I'm going to jump out of the Hangout, and I'll get back in.
All righty, here we go, everyone. So like Tim said, we're at different places across the country. I'm not too far from you guys. I'm over in eastern Idaho there in the wonderful, thriving metropolis of Pocatello, or as we like to officially call it, Pokey. And Tim, again, is in El Paso. He's down there in the far southern end of New Mexico. And Jamie's over in Raleigh, and they're in the Carolinas. So you can see we have quite a few offices across the country. You guys are handled by the Portland office there in your area, but we have 122 offices across the country. That includes Alaska, Hawaii. We also have offices in Puerto Rico, in Guam, and is it Pago? Was that? Can't remember if we had. I thought we had one there.
Yeah, you're right.
Yeah, it's one of those. I could pronounce it wrong every time. So anyway,
let me stop you for a second, Miss Crystal. Are you able to see the slides, or are you just able to see? Who are you seeing right now?
We see Tim frozen.
Here I come. Here I come.
There we go. It didn't want to switch over to me either there. So apparently, whatever Tim did temporarily locked it. At least it was sharing the screen for us. But there you go. You can see again where our offices are located. You guys are handled by Portland. I'm over here in the Pocatello office. Tim's down in El Paso, over in Raleigh. So we've got a ton of offices that handle our duties across the country. So now moving on, you'll notice if you think about it, the sun is where everything starts, whether it's hot, cold, any type of weather, that is all started with the sun. And the reason that is, the sun heats the earth, and that earth heats up that air. So you may hear people talking about radiation, solar radiation, heat radiating from the ground. And basically, the sun produces radiation that reaches through the atmosphere and is absorbed by the Earth's surface. And at some point, you have outgoing radiation that is absorbed by the atmosphere. So in some point in time, there's actually a balance. So you may, depending on how much is coming in from the sun to the ground or how much is leaving the ground back into the atmosphere, you may see varying types of weather and temperatures as well. Obviously, when you're getting a lot of radiation, it's pretty warm to the ground. But once you start climbing, in most cases, it's going to be cooler as you go higher in the atmosphere. There are a few cases where it's actually not. And that's, if you ever heard of the term inversion, That's an example of when the actual temperature profile reverses. Instead of cooling as you go higher, it gets warmer as you get higher. Now, you'll notice on this particular map here, there is uneven heating of the surface of the Earth. And a lot of times you have what we call the vertical rays, where you get more radiation is received by the Earth, and the oblique rays where less radiation is received by the Earth. And that actually plays in, if you think about it, it's a lot warmer in the equatorial regions because of higher sun angles in pretty much all the time. When you get into the polar regions, it's usually colder on average because you have lower sun angles in those particular areas. So, and you'll notice the Earth is always tilted. I'm sure you guys have heard of Earth's axis being tilted, and that actually can play a difference into how much sunlight we get, and also in a few other things as well. With the sun rays at the equator, you've got the sun angle at 90 degrees. You'll notice as you get farther towards the poles, the sun angle decreases. So by the time you get into our neck of the woods and up towards the poles, the sun angle is closer to 23.5 degrees. If you go south towards Antarctica, it's doing the same thing as well, just depending on the Earth's axis and how it's tilted. Now, when we talk about the equinoxes and solstices, you'll notice that changes. When we're at the equinox, the spring equinox and the vernal and autumnal equinoxes, you'll notice that's pretty much where the angle of the Earth would be looking like. Now, you get to seasonal differences with the summer solstice. You'll notice the Earth is tilted on its axis in one direction, and you'll notice that the sun angles change, especially between the poles. But again, with summer, you'll notice down towards the Tropic of Capricorn, the sun angle is closer to 23.5 degrees there, versus towards the pole, the sun is a little closer to 23.5 degrees sun angle there as well. You go towards the winter solstice, and you'll notice the Earth is tilted completely the opposite direction. So a lot of different things play into how we see temperature changes, things like that. And a lot of it has to do with the sun and the tilt of the Earth. And you'll notice as the seasons change, that's because the Earth is revolving around the sun. That sun tilt, the tilting on its axis, plays into those seasonal changes as well. So, and another thing to talk about is how things heat differently. You may notice like something metallic heats different than a different type of material as well. Well, land and water heat differently. The land is going to heat faster and have higher temperatures than the water. The land will also cool faster and have lower temperatures than the water as well. So think about that when you're talking about some of the different weather phenomenon you might see. You might see some different weather going on because of that temperature difference between land and water. And that uneven heating also leads to uneven pressure distribution. And I'm sure you've seen your local meteorologist there talk about high and low pressure on a map. You might see the big blue H or the big red L on a map, a cold front or such as well. That's because of the uneven pressure distribution. I'll get that out right in a moment, across the entire globe. So when we talk about high and low pressure, air is always going to be moving from high to low pressure. That is how things balance out, high to low pressure. Now, that moving of the air, I'm pretty sure you guys have gone outside when the wind's barely blowing or strongly blowing. That difference between high and low pressure determines the strength of the wind. But again, high to low pressure, that's how things are going to move when you're talking about wind and the air pressure in general. So here's a question for you guys. Remember back just a couple of slides. Because of the Earth's tilt at 23.5 degrees, what do we get? Do we get day and night, gravity, the winter, spring, summer, and fall seasons, or the lunar cycle? How many think it's 1, 2, 3?
Yes.
Yes. I can go with 3, I think so. And believe it or not, that is actually the answer. So good job, everyone. Give yourselves a round of applause. We have another question for you. Again, talking about the Earth's axis, the tilt, and how the Earth rotates around the sun. When it's summer in the northern hemisphere, What season is it in the southern hemisphere? Is it summer in the southern hemisphere when it's summer in the northern hemisphere? I don't see any hands for that one. Oh, I hit the button. I'm sorry. I gave it away. What do you know? I got ahead of myself. So it's winter. So it's number 2. So go ahead and raise your hands for number 2. There you go. Occasionally on a test, you might get a freebie. I don't know. But anyway. And again, do you want me to keep going, or do you want to take over from here, Tim?
I'll take over from here if you don't mind.
Go right ahead.
Very good. So sorry about the technical glitch there. All right. So Mr. John's gone ahead and covered, and he talked about the interesting thing, how the Earth is heated up by the sun, and then the Earth then warms the air from below. He talked about how the Earth is round, and we get that uneven heating. He also talked about the tilt. We get the 4 seasons because of the tilt of the axis, and as we work our way around the sun. Talked about the water, how water and land heat up differently, and that leads to those areas of high and low pressure. And that's kind of interesting. Those areas of high and low pressure, they give us so much of our weather. And I'm going to try to share my screen again. So let's see if this works. Ooh, I like it when it does that effect. So can you see my screen now?
Yes.
All right, but it looks like it's way back at the beginning, doesn't it? All right. Okay, so I'm going to jump ahead. So I apologize. Here we go. There's the answer, and there's the answer again. Okay, so here we are. So for high and low pressure, you've seen that on the weather map. John kind of showed you on the weather map. You may have seen it on a weather map on the internet or at home on the television, where you've got these areas of high pressure, these H's, and these areas of low pressure, the L's. And with the high pressure, like John said, the air is always trying to run away, or we call that diverge. That's a big science word. The air is trying to run away from the high pressure. And as that air runs away from the high pressure, air from above kind of sinks down because there's kind of some air missing above that area of high pressure. So you get this sinking air. And because you get that sinking air, you get that's the exact wrong conditions that you need to get clouds. So actually, when you have high pressure, many times you have sunny skies because you have that sinking air versus the area of low pressure where all that air is rushing in. Like Mr. John said, all that air is going from the high pressure to the low pressure. And as that air all rushes into the low pressure, it bumps into itself and then it kind of squeezes. If you guys have ever squeezed like toothpaste, kind of squeezed it up, that's what happened is as the air kind of converges there on that area of low pressure, it kind of squeezes itself up. It can't go down into the ground because the ground is hard, but it can go up. So it starts to go up into the air. And when you start getting rising motion in the atmosphere, that's when you can start to get clouds. That's when you can start. And once we get clouds, then we can get all kinds of interesting weather associated with those clouds. Now, jumping real quickly back to the high pressure. The high pressure, I tell people the key for the high pressure is the H, because I can kind of give you a clue as to the weather associated with the high pressure. So we tell people with high pressure, you can expect happy weather most of the time. Kind of the H there kind of gives it away. And that includes like clear skies, calm conditions, dry weather. It'll be warm during the day, and it may be cooler at night because we don't have any clouds. The clouds a lot of times act like a blanket for us. They act like a blanket for the temperature, and at night they'll keep that temperature kind of warmer than it would normally be, especially in the desert regions where you get real warm during the day and then it actually cools down a lot at night because there's no cloud cover at night. Now the opposite happens as well. With this area of low pressure, the L is the key. And I tell people low pressure brings us lousy weather. A lot of times it'll bring us cloudy skies, windy conditions, wet weather, and many times it'll be followed by colder weather. And I'll show you here on a map why that is here in a second. But it's that lousy weather that as all that air rushes into that area of low pressure that gives us our wind. As it lifts up, it gives us our clouds, and then we can start to get all kinds of interesting weather once we get clouds going. Now, here's perhaps a more typical kind of weather map where you have the H and the L, and then coming out of the L is a warm front and a cold front. So you got the high pressure over New Mexico, you've got the low pressure over the Texas and Oklahoma panhandles, and then you've got a red line coming out of the low pressure. That's the warm front, and you got a blue line coming out of the low pressure center. That's the cold front. The way the air kind of moves around on the Earth, it moves in chunks sometimes. and sometimes one chunk is warmer or colder than another chunk. And as these chunks move along, we denote them, or we kind of mark them off on the weather map with the leading edge of them being marked off by these fronts. So in this case, you can tell which direction the cold front is moving by which direction those little blue triangles are pointed. So in this case, the cold air is moving out of New Mexico and into Texas. You can also tell the same thing with the warm front. It just shows you where the warm air is replacing the cooler air. In this case, you can tell which direction the warm front is moving because of those red semicircles. They point in the direction that the warm front is moving. And in this case, the warmer air is moving from the south, or from the bottom of the screen up towards the top of the screen. So the warm air is moving out of Texas and into Oklahoma. Now I'm going to show you here in a minute on a map that kind of is closer to home for you guys, how it looks like as that cold front moves across your region. But before I do, I want to talk real quickly about the differences between the warm front and the cold front. Now, the cold front, as it pushes along through the atmosphere, it acts like a big bulldozer, a big wedge as it wedges along. And if you've ever seen like a bulldozer in the construction area, as it pushes up that dirt, it's making that pile of dirt higher and higher. Well, the cold front does the same thing. As it wedges along through the atmosphere, as it's pushing through the air, it pushes up the air in a very vigorous, very strong way. So again, there's that lifting motion. Once you get that lifting motion, you can start to get the clouds. And with the cold front, many times, since it's lifting it so quickly and so vigorously, you can actually get thunderstorms right along that edge of that cold front. Versus the warm front, which is down in the lower right-hand corner of the screen. That warm front, yes, the warm air does kind of go up, but it doesn't go up very quickly. The warm front moves much more slowly than the cold front, and that slope that it goes up is not very steep at all. If you've ever pushed like a grocery cart or a shopping cart into a grocery store or into Walmart, if you've pushed it into it, you know you kind of sometimes go up over a little ramp. Yes, you've gone a little higher, but it wasn't very steep and it was pretty easy to do. The same thing happens with the warm front. As that warm air kind of slowly rides up over the cooler air it's replacing, you can get some clouds and you can actually get some light rain or drizzle, but it's nothing like the clouds that we can get with the thunderstorms with the cold front. So if you've ever had a day when it's kind of been, you've seen the one cloud from one side of the sky to the other. It's kind of flat on the bottom. It's gray all day long, and you maybe get light rain or drizzle at the bottom of it. It may have been a warm front in your area, kind of giving you that kind of weather, versus that cold front where you have those big white puffy clouds right along the front edge of the cold front, and that's where you can get your showers and your thunderstorms right along with that cold front. All right, I know that today is Wednesday, but I made up some pretend weather for you guys just to kind of demonstrate what it looks like when a cold front goes across here. So let's pretend it's Monday, and let's pretend like these are the temperatures across your area. So in this case, this is probably maybe late spring, maybe early summer, where you got temperatures in the upper 70s to near 80 degrees, maybe even over to where Mr. John is. It's in the low 80s, 82 there in Pocatello. Seattle's at 78. But you can see they're right over, right north of Seattle, there's an area of low pressure. It's just barely peeking out there over southern Canada. And you see that cold front dangling down from it. And you can tell which direction this cold front is moving because of those blue arrows. Now, if I jump ahead 24 hours, now you can see how the colder air has moved across part of the area. What was in the upper 70s in Seattle now is in the mid 60s. Same thing for closer to where you guys are near Portland. You're now in the mid 60s. But out ahead of that front, in that what we call the warm sector, where the front hasn't gotten to in Boise and Pocatello, it's still in the the low 80s. If I move ahead again another 24 hours to Wednesday, now you can see the cold air has moved across almost the entire part of the region. So it's much cooler behind that cold front. But you can still see Pocatello still in that warm, what we call that warm region, that warm sector. And they're still in the low 80s versus everybody else who's near 60, maybe in the low to mid 60s. Now I'm going to jump back 48 hours here. And instead of looking at the temperatures, we're going to take a look at the weather associated right along that cold front. And right along that cold front, you can see from Seattle to Portland, you've got those thunderstorms right along that cold front. Maybe behind it, you've got some light rain showers. And then out ahead of that cold front a little further, you can start to see in Eugene, maybe in Medford, you can start to see the clouds beginning to build up because as that bulldozer, as that wedge of cold air is beginning to push in, it's starting to lift up those clouds, lift up the air to get you those clouds. But if you look all the way over there in Idaho, in Boise and Pocatello, they don't even know a cold front's coming. It's nice sunny skies there. So if I jump ahead another 24 hours, now you can see how the thunderstorms run from Burns over to Baker City. You got some light rain, and then the clouds are beginning to build up in Boise. And you can see things are beginning to clear out on the backside of the cold front. Seattle, Portland, Eugene, and Medford. The sky's beginning to clear as that high pressure builds back in. And remember, that high pressure, we usually get that happy weather. If I jump ahead another 24 hours, now you can see the thunderstorms are centered near Pocatello. You got light rain there in Boise. And you can start to see you got lots of sun on the west coast there from Medford to Seattle. It's cooler there, but they do have sun. And you can start to see the sun beginning to come out in Baker City and Burns and Spokane. So that's how kind of that cold front, as it would work across the northwest region of the United States, might look. It doesn't always work out like that. And we're going to talk about sometimes you can get a cold front going through and you don't get any showers or rain at all. Mr. Jamie's going to talk about that here in a minute. But before we get into the next section, I think I got a question for you. So here's a question for you. The most common type of weather is associated with, let me start again. What is the most common type of weather associated with high pressure? Is it 1, cloudy skies, 2, gusty winds, 3, sunny skies, or 4, thunderstorms? What do you guys say? What do you think? Do you think it's number 1, 2, or 3? Go ahead and hold up your fingers. Let me see. Oh, I'm seeing numbers. I'm seeing, looks good. I'm finally getting, I see some 1s. I see some 2s. Very good. Let's get back over to my screen here and share it. And so the correct answer is number 3, sunny skies. Remember, with that high pressure, you get those sunny skies. All right, I got one more question for you here. You guys ready? Here we go. So the most vigorous weather, what we call maybe thunderstorms, occurs with what kind of front? Is it 1, the warm front, 2, the cold front, 3, the occluded front? We didn't even talk about that one. Or 4, none of the above. Hold up your fingers. Is it 1 or 2? What do you guys think? I see some 1s. I see some 2s. I see a lot of 2s. Hey, good answer, because the correct answer is cold front. A cold front is where we saw those most vigorous kind of those thunderstorms right along that cold front. So good job there, everybody. Talking about getting those temperatures and everything that way. With that cold front as it moves across, we get those cooler temperatures. So you guys did a great job in paying attention. But it doesn't matter if you have all the low pressure centers in the world. It doesn't matter if you have all the high pressure or the cold fronts in the world to give you all that lift. If you don't have moisture in the air, you're not going to get any clouds. And I'm going to let Mr. Jamie talk about the importance of water and how important it is to making our weather. It's a pretty important thing, isn't it, Mr. Jamie?
It is, Mr. Tim. Thank you so much for everything there. So we're going to talk a little bit about water, and we talked a little bit earlier about the sun and how important the sun is for weather to actually occur on Earth. And the number 2 most important element on our Earth is actually the presence of water. And one of the most interesting things about water is that it actually is present in 3 different phases of the same molecule. So we'll talk a little bit about the solid phase, and the solid phase is more of that ice cube that you may have floating around in your drink. It's also a liquid phase and a gaseous phase. And gas, a lot of times you cannot see it, but it's around us at all times. We have oxygen around us, hydrogen around us, and all different types of gases that are right here in our area. So we'll go into a little bit about the changes that these phases go through and what it actually will mean in the presence of weather. And Mr. Tim, I actually just see me and I don't see any of the slides. So
okay, so you want me to go ahead? I'll go ahead and run this. So can everybody see me on the screen right now?
Yeah.
Excellent. Now the next question is, boop. I know it's always cool when it does that. It's kind of freaky. All right. Can you see what it says? Water, an amazing molecule.
Yeah.
Excellent. Continue on, Mr. Jamie.
All right. So we'll actually talk about some of the things that this water can do and how it changes from both solid, liquid, and gas. And we'll talk about some big words here. It's not important that you understand what the words are, but I do want to talk a little bit about how each one goes from what. So everybody knows what liquid water is. You know, there's a lot of liquid water on the surface of this planet. We see it in our oceans, our rivers, even in our glasses sometimes at dinner. So water in the liquid form is everywhere. But what we don't realize is we also see water in the atmosphere almost on a daily basis. That may not be true for those that live in the desert like Mr. Tim. He doesn't get to see him as a gaseous water phase. But for us, especially in Washington State and again in the East Coast, we see water vapor, which is what the gaseous phase of water is called, almost at all times. So from liquid to a gas, that's called evaporation. So in this process, and it happens every day, you get water that starts to evaporate from the oceans, and it turns into a gas, and in that gas is what actually fills up a lot of this water. And through the method of condensation, we start to see that water droplets again in the form of clouds. But when it comes from the clouds and back down to the earth, we actually, and let me rephrase there, condensation is when it goes from the clouds back to a liquid. So that's when you see those clouds start to form. But when you actually see it go into more of a solid phase, that goes through deposition. And what deposition is anytime you see that liquid droplet fall down, but in a solid form. So we're talking snow and maybe sometimes even sleet. If you ever see those, especially if you venture into the eastern mountains of Washington State, that is the method of deposition when it goes from a gas to a solid. And also it can go from a solid back to a gas in the method of sublimation. So these are some big words. The main ones you want to know is condensation, and that's when it goes from a gas to a liquid. Melting when it goes from a solid to a liquid, and refreezing when it goes from a liquid back to a solid. So those are the main three. And what's really important with all of these is it actually makes up what we call the water cycle. And that's the next thing we'll talk a little bit about. So we already made reference to this. We'll start from the ground up. So a lot of times we have liquid water on the surface of our planet. And through evaporation, we actually get that liquid water into a gaseous form. And as that gas starts to rise, it actually starts to cool, and then eventually it condenses back in to liquid water inside of a cloud. And that's through the method of condensation. Once the cloud gets a little bit too heavy, it actually turns and allows that rain to fall in the form of precipitation. So you hear about rain, snow, sleet, all types of different wintry precipitation. All of that is going from that condensated water nuclei back down to the surface. And when it hits the surface, we have what's called surface runoff. And that's when the water lands on the surface, goes into the drain, eventually flows into streams, creeks, rivers, and then sooner or later it goes into the bay and back into the ocean, and it can start the whole process again. And without this process, we actually would not have life on Earth, because you would run out of water at some point. But because of this process, we're able to recycle all of the water that we have on our planet. And without this water, we certainly wouldn't have weather beginning to occur, including one of the more devastating and strongest types of weather in the form of hurricanes. Does Washington State get a lot of hurricanes out there? No, not really. But a lot of the United States, if you guys decide to venture a little bit further east or even further south into parts of California and eventually into Mexico, there are some threats of hurricanes. So we'll talk a little bit about what is the greatest storm on Earth and what they're called all around the world. So if a hurricane were to venture up north and east all the way to the Washington State area, which would be very, very, very rare, but if ever did, we would call it a hurricane. But if you would decided to go on a cruise into the Indian Ocean, we actually call the same type of storms in the Indian Ocean cyclones. And it's the same type of storm, just a different name. And also the Western Pacific, so if you decide to go to China or Japan or Thailand, we call them typhoons. And one of my favorite names out there is if you decide to go to the coast of Australia, they're actually called Willy Willies. Isn't that a funny name? So Willy Willies are the same storm. They actually rotate the different way because they're in the southern hemisphere, but they're actually the same storms that we see. And a lot of times we see these storms mainly in the Atlantic and the Pacific. So let's talk a little bit about the ingredients needed for these storms to occur. Hurricanes are really the main fuel source that they are needed to breathe are warm ocean waters. And those warm ocean waters really start to heat up in the Pacific and the Atlantic during the summer months when the sun is pointed directly at the waters. And those waters tend to really start to heat up, especially in the July, August, and September months. And when that water heats up, that evaporation process produces a lot of water vapor, and storms start to form. And anytime you have light winds aloft, those storms will begin to organize into a much larger cluster of storms and eventually into what we call a hurricane or cyclone, depending on where you are across the country. And whenever the cyclones do form, they can be very dangerous to everybody that's in their path, including people on boats, but also people on land. We recently had a couple of hurricanes impact us here in North Carolina this past year. So let's take a vertical slice of what a hurricane may look like. And we'll start from the inside and go outwards. So first of all, if you're right smack dab in the center of the storm, you're in what's called the eye of the hurricane. And that eye typically has the calmest winds in the storm. You're saying, well, Mr. Jamie, that's the middle of the storm. How's it the calmest winds? Well, think about a drain in your bathtub or your sink. And a lot of times there's actually no water going down the middle of that drain. That's because all the water decides to go around it. So there's like an eye in the middle of that storm. But the calmest conditions are actually inside of that eye. And that's the same with the hurricane. You have really light winds. You actually get mostly sunny skies. And there's reports of people going outside thinking the hurricane's over just to have the eye wall, which incorporates the strongest conditions in a hurricane, come through and actually potentially injure them or damage their property. So it can be a very dangerous thing if you find yourself in the eye of the storm. So like I said, the eye wall has the strongest winds and oftentimes the heaviest rains. And oftentimes we're actually talking 100 mile an hour amount of wind or greater with larger gusts. And as you expand outwards within the storm, we have what are called spiral rain bands. And those rain bands can stretch hundreds of miles in each direction. And they can have moderate to heavy rain, very strong winds, and even a possible weak tornado or two. When Hurricane Florence came ashore across the North Carolina coast this year, we had anywhere from 10 to 25 different tornadoes touch down as those rain bands were pushing through. So hurricanes have a lot of depth. They have a lot of strength, and often they can impact several states, not just one neighborhood, like some thunderstorms may impact. All right, so we'll go on and talk a little bit about some of the differences between weather and climate. So let's start with weather. Weather consists of the short-term outlook, and that could be anywhere from a minute from now to several days from now. And it talks about the variations in the atmosphere. So weather often expresses in terms in temperature, humidity, precipitation, how many clouds there are out there, and how you can able to see or feel. So we're talking visibility and wind. So weather is what's going on now. On the other hand, climate is what is going on over a long period of time. So climate is the average weather over in a particular place over many years. So if you're asking me, Jamie, what's the climate of Washington State? I'll tell you, over the last 30 years or longer, Washington State usually sees a lot of rain and a lot of snow in the mountains. But he asked me the weather for this week. I may tell you it's going to be sunny all week. So that doesn't really match up between weather and climate, but because they're talking about two different things. So climate can actually talk about hundreds, thousands, or even millions of years of change, while weather is really looking at the first 2 hours to up to 10 days. So weather happens at a particular time and place, while climate is a regional and long-term term. And so for weather, you're talking about what's happening now. But if you're talking about history, we're talking more about what is happening and what is possible in an area's climate. So climate is what you expect, while weather is what you get. And you can see this faded time series there. That's actually looking at looks like several years, if not up to 50 years of data in there or longer. I'm not 100% sure what this is showing. It looks like about 10 or 20 years of data in there. That's more talking about climate. But if you wanted to know what was going to happen in the next 2 to 5 days, we would talk about weather and weather patterns. So those are the main differences. And I think I have a couple questions for you. First up, and you guys raise your hand and let me know what you think. What is the main fuel source for a hurricane? Is it 1, warm ocean water, 2, peanut butter and jelly sandwiches, 3, the rotation of the earth, or 4, cold ocean waters? All right, what are you guys thinking? All right, I see a couple of ones. Great job. So it's not 2. 2 is
Not
my
two.
fuel source.
That's my favorite.
But it's not the main fuel source of hurricanes. So you're right. Hurricanes really need that warm ocean water to work. So I just need a lot of peanut butter and jelly to come on these presentation calls. All right. So now, true or false question. Climate is the average weather in a region over many years. What do you guys think? Is that true or is that false? All right, I see some people holding up ones, a few holding up twos. Let's see what the answer is. You guys are right. You got a number 1. True. Climate is the average weather in a region over many years. We can talk about 30 years or up to hundreds of years. And that's, we're talking more about climate. So I'm going to pass this back to Mr. Tim. I think we may have a couple of minutes for some questions, and I'd love to hear from everybody.
Yeah, so very good. Thank you. So that's basically the presentation. We started at the beginning, kind of told you where the weather came from. Then Mr. John talked about the differential heating and how the sun shines on us, and we get our 4 seasons. We get the high and the low pressure forming. The high pressure gives us happy weather. The low pressure gives us lousy weather. We talked about how cold fronts bring in that colder air. Mr. Jamie talked about the weather versus the climate, talked about hurricanes, and then he also covered the water cycle. So that was a lot of ground to cover, and we went through it pretty quick. I appreciate you guys just sitting there and listening and answering the questions and paying so good attention. But I was wondering, do any of you guys have a question for any of us? And I guess if you could, Miss Crystal, if you could call on somebody for us.
What is your weather like today?
So I'll go last because I believe I probably had the most interesting weather. I don't know, but I know John had interesting weather last night. So Mr. John, tell them what you had last night and what's going on right now.
Well, certainly last night, some of that wonderful moisture that came from Washington the last day or two, we ended up actually with snow here in eastern Idaho. And I know at my house, I live a little bit off the valley floor. I had 4 inches of snow, just under 4 inches of snow last night. I know here at our office, we had just half an inch. And that's interesting because the office is only about 10 miles from my house and at a different elevation, but that can just tell you the different types of weather you can have over a shorter distance or an elevation change. Today, we do have a little bit of snow out there. The big thing for us, it's windy, and we've got some areas that are seeing some wind gusts 30, 40, 50 miles per hour, and that's actually causing some problems. People can't go to Yellowstone today from in eastern Idaho, at least the direct route. Blowing and drifting snow caused a wreck here in the last couple of hours. So pretty interesting weather. Definitely not feeling like it was a couple of days ago when it was in the 60s.
Very good. Mr. Jamie, what do you got going on there on the East Coast? Oop, you're muted, sir.
Sorry about that. Luckily, my weather has quieted down since the last couple days. We had a lot of storms go through early this week, so we're still cleaning up from some damaging winds and even some large hail out here in central North Carolina. But today was not that story. We actually had some very nice weather. We have a cold front that went through, and as we talked about the cold fronts, that's nice cooler weather. It's a light breeze, and all that wind is coming from the north, kind of like Canadian type air mass. And usually those air masses are cool and very pleasant. So we had a high around 65 today with a nice cool northerly breeze. So we're thankful for that and looking forward to more storms later this week.
Very good. And like I mentioned, I'm kind of like Mr. John. I do have some wind, but I was going to show you my screen here. This is what the current conditions are in El Paso. It's blowing dust, windy, 79 degrees, so we're pretty warm. But the winds are at 30 miles an hour, gusting to 58 miles an hour. And the visibility is about 2 miles. And you can see all the highlights that we have issued. Matter of fact, right before I came talking to you guys, I issued the blowing dust warning for El Paso. So definitely some interesting weather here. We were 92 yesterday, so we were nice and warm. We're cooler today, but it's very windy and very dusty. Lots of blowing dust in our air right now. And I know Mr. Jamie's got, what do you got on the screen there?
Yeah, don't mind me as I'm putting chapstick on after seeing a humidity of 7% down there, Tim.
It's true.
That is very dry and something that Washington State will never see, and the same here east of the Appalachians. But what I'm showing you guys right now is actually the radar overhead. And if you're looking at this closely, if I remember right, you guys are right around this area here.
Yeah.
And it looks like there's your rain coming ashore and what's been coming ashore all day, especially out at recess. So for those of you who brought a rain jacket for recess, you guys were being a meteorologist already today because you had a lot of rain in the area, and it looks like a little bit more rain to go later on this week.
Right here, guys.
You know, I find it interesting that I looked at your guys' forecast there in southern Washington. You got like 100% chance of rain today, and then 90% chance of rain tonight, and then it takes a little break, and then it's 100% chance of rain again. Here, this is your rainy season. Where I live in the desert Southwest, this is our dry season. It is not uncommon for me to go the entire month of April with 0 in our rain gauge. It's just a dry time of year. So it's kind of interesting how we all live in the same country, but different regions of the country have this different weather that's going on. So while you guys are so wet, the desert Southwest is so very dry right now, and it's kind of amazing how that works out. So that was a great question.
Any other questions? Jackson.
Do you take questions from, do you look at the weather from other countries or continents maybe?
Very good question. I have to, like Mr. John showed you, I'm down in El Paso. So we are right along the U.S.-Mexican border. So we do have to pay attention to what's happening down in Mexico and the weather associated down there because sometimes the weather kind of comes, generally the weather goes from the west to the east, but sometimes it comes up from the south and then kind of heads off to the east. So as a matter of fact, today, and while the others are talking, I'll show you on a map here, if I can dig it up, all the dust that's coming up out of Mexico right now and moving across our area. So yes, for me, I have to pay attention to what's going on in other countries, in Mexico in specifics. But I don't know about John, if you got to look up to Canada anytime to see like where cold air is coming from.
Certainly, we do have to look up in Canada. We do have some cold air that does come from there. What's interestingly enough, and you guys in Washington see some of the same things we do, we have to sometimes watch the weather all the way across the Pacific Ocean over towards Asia, China, Japan, because sometimes we get these huge storms with a lot of moisture that come from those areas. A lot of times you may hear your local meteorologist or the Weather Service office there talk about an atmospheric river, and it's not a river like you think it is, like the Columbia River that runs through that area in the general area. It's a big flow of moisture that comes from other parts of the world, and that can fuel some real heavy rain, especially along the coast there. A lot of times when we get those big rain events on the coast of Washington and Oregon, that's an atmospheric river. Sometimes that comes from Hawaii, but sometimes that's left over from maybe a typhoon or a big storm that develops way over in the Western Pacific. So we do have to look a lot of different places. I don't know about you, Jamie. What do you have to look at? On the opposite side of the U.S.
That's right. We're on the other side of the U.S., and we're really far from any other country, but it's still really important for us to know what's happening across our entire country and in parts of Canada, Bermuda, to our south and east in the oceans, and also the Gulf of Mexico, because all of those regions are what we call forced regions for air masses. And if air is coming from Canada, we know it's going to be colder. If it's coming from the ocean, we know it's going to be warmer. So knowing exactly what's going on with all that is really important in everyday forecasting year-round for us here in the eastern half of the United States.
Very good. Let me show you real quick what's going on again. Like I said, we've got very active weather here. Here's a kind of an image. It's kind of hard to tell, but all this pink that you can see on the screen coming up, El Paso's right here. And all this pink coming up out of Mexico is just dust. And this was earlier this morning, about 4 hours ago. If I jump ahead here, you can see what it looks like outside right now. It's pretty dusty. If I jump all the way up here, you can see now all that pink is filled in. We got lots of dust, and we kind of circled some of the main dust areas. So lots of dust is happening right now. And like we were saying, everything down here south of El Paso is all coming up out of Mexico. And it's important for us, again, to see what's going on down there because it will have a weather impact here, just like John and Jamie said.
You probably have time for one more question. Lincoln. He's our scientist here.
What kind of technology do you use there?
Excellent. What toys do we get to play with was the question. I like it. You know what? I will talk about some of our simpler toys, and I'll leave the more kind of exciting toys to John and Jamie to talk about. But you know, some of the simple things that we use is you know, what happens when you guys get sick? How does your mom take your temperature? Thermometer, right? You know, we use thermometers all the time because we have to measure the temperature of the air. But we also use other kind of instruments. We use an anemometer, which is that thing with the cups on it that spins around like that. We use a thermometer, an anemometer. We use a hygrometer to measure the atmospheric moisture. You know how much, you know, when Mr. Jamie was talking about the water in the air, that measures how much moisture is in the air. We use a wind vane to tell which direction the wind's blowing. We use a rain gauge to kind of figure out how much rain has fallen. Now, those are all instruments that you guys can either, you know, get real easily or even make. You know, it's easy to make a rain gauge. You take a 2-liter bottle, you cut off the top, you flip the top upside down, you've got a rain gauge. So, you know, those are some of the tools that you guys can even make and become your kind of amateur meteorologist yourselves. So those are some of the simple tools that we get to use. I'm going to have Mr. Jamie talk about another tool that we use to help us to forecast the weather. Mr. Jamie?
Oh, thanks, Mr. Tim. And hopefully I'm sharing my screen okay. But
yes,
that's good. Awesome. One of the really cool tools that a lot of our meteorologists get to work with are called weather balloons. Have you guys ever seen a weather balloon before?
No.
So take a look. These are some of my student interns. So if you guys get into high school and college and you work or you go to school near a weather service office, they may have a program for you guys to get into if you're looking into this. But these are student interns right before they're launching a weather balloon out of Greensboro, North Carolina. And there's actually 82 different places across the United States and hundreds of places across the globe that actually launch these weather balloons twice a day. And these weather balloons measure all the important weather ingredients, including temperature, humidity, wind, dew point, all of the really important things, not just at the surface, but way above where the airplanes fly. And what we do is we use that information to go into our forecast models, and it helps us do our job everywhere across the country. So without these weather balloons, it would be very hard for me, Mr. Tim, and Mr. John to do our jobs very effectively. And I know Mr. John also uses this type of equipment when he's working with fires. So I'll punt it over to him.
Oh, certainly, yes. When we're out on fires, we actually are able to launch balloons to get local weather, and that also could be fed into some of the models as well. And speaking of fire, I wanted to show something here really quick. I know we're getting close to our end of time here, but what if this will work? Let's see. There we go.
Ooh,
now, this is a satellite image. Now, satellite, a lot of times you say, well, we look at clouds and such on satellite. This particular satellite image can actually detect the heat from a fire, and this is a fire over in the Albuquerque area, not actually too far from where Tim is right now. Tim is right now. So, but this is actually picking up the heat signature off of a fire that's occurring there in the state of New Mexico. So certainly some interesting things we can do with satellite. And of course, you saw earlier we had the Mr. Jamie was showing you radar there in Washington. So radar and satellite, those are a little more sophisticated toys that we get to play with, but they can give us a lot of information that you may not even actually we may never show you, or your local TV meteorologist will never show.
So yeah, we get to play with a lot of cool toys. So I encourage you guys, if you ever want to be a scientist, be a meteorologist, or anything like that, we got a lot of cool toys to play with. Well, I think we're out of time. Is that not correct?
Yes, we are.
All right, we'll let you guys go. Thanks for joining us, and thanks for hanging around through the little technical problems. You guys have a great day. Bye-bye. Stay safe. You bet you guys, you did a great job. Enjoy the weather and stay safe.
Thank you so much.
Bye.